Hello, and welcome to this CDP Studio tutorial. In this tutorial, I will show you how to set up and use a Phoenix Contact PLCnext AXE-F 2152 with CDP Studio. The tutorial will show you how to add a PLCnext I/O component into your project and how to add I/O modules to the PLCnext I/O. I will show how to use CDP Studio to set up automatic scaling from engineering values into hardware values. We will use logical units such as -1 to 1 in the user interface, while the scaling operators will transform this into hardware values representing -10 to 10 volts. I will also show how to set up alarms to notify the user when something is wrong, and finally I will connect everything to user interface. I assume you have already installed the CDP I/O add-on from the PLCnext store onto the controller. For more information about this, see the help about PLCnext I/O or check out the video tutorial on installing the CDP I/O add-on. The PLCnext controller I have here in my office is set up with two modules, a dual analog input-output module and a 16-in, 8-out digital module. The analog module is wired so that the first analog output is connected directly to the first analog input as a voltage signal, effectively looping back the value. The first digital input is connected to a button, and the first digital output controls a light. The I/O server user interface that was made in the I/O server user interface tutorial will be used here to demonstrate how the I/O integration works. I recommend looking at that video first if you have not yet seen it. Open CDP Studio and then load the I/O server user interface from the I/O server user interface tutorial. In Configure mode, right-click the system, select Add CDP Application. We then add a console application that we intend to run on the PLCnext target and name it PLCnext App. Select the application that was added and from the resource tree, add a PLCnext I/O component into the application. The PLCnext I/O component is a CDP I/O server that converts CDP signals to values that the PLCnext understands and converts PLCnext I/O values into CDP signals. With the component selected, in the resource tree, you can find all the available I/O modules for the PLCnext under the Phoenix Contact I/O modules node. Please note that in version 1.0 of the CDP I/O add-on, it is not possible to change the individual configuration of the I/O modules, such as changing from ±10 volts to 0 to 10 volts, and other similar changes. For that, you need to use the PLCnext software. The PLCnext I/O FS property decides how often the inputs and outputs are updated per second. Since no device has an infinite amount of processing power, you should set this to a reasonable number depending on your application. As we are looping values from output to input, the default 100 Hz setting is OK for our use. Select the PLCnext I/O that we added. We now want to populate it to be similar to the physical module. As I mentioned in the beginning, my PLCnext has an AI2 AO2 module and a DI16/1 DOA/2 module attached, in that order. We add these modules to the PLCnext I/O configuration by searching the resource tree. Search for AI2 and from the suggestion list, double-click the AI2/AO2 module to add it. Then search for DI16 and double-click the DI16/DO8 module from the list to add it to the PLCnext I/O. We want to work with sensible names when we configure the system. So, from the module table, rename the first module to M1 and the second module to M2. Then go into the analog module called M1 and rename AO0 to speed out and rename AI0 to speed feedback. As you may remember from the I/O server user interface tutorial, we wanted the values to range between -1 and 1. If we look into the Phoenix contact documentation for the AI2-AO2 analog module, we can see that for ±10 volts, it expects a signed 16-bit value ranging from -30,000 to +30,000. In CDP Studio, we typically handle this conversion from engineering units to hardware units by using a scaling operator. Select the speed out signal and in the resources search for scale and add a scaling operator of type double. Select the scaling operator and add 2 scaling points. For this tutorial, we want to use the ±10 volt range for the I/O. Go into the first scaling point and set the in value to -1 and the out value to -30,000. Then go into the second scaling point and set the in value to 1 and the out value to 30,000. We have now created a scaling so that when we set -1 to the speed out signal, it will send a value that makes the I/O module output -10 volts. Similarly, when we set a value of 1 to the speed out signal, it will be scaled to a value that causes the I/O module to output +10 volts. We add similar scaling points for the speed feedback channel, but since this is a physical input channel, the inside is close to the hardware, so the scaling value in is -30,000, while the out should be -1. For the second scaling point, 30,000 should convert to 1. We also want 2 alarms for the input. One when the speed is too high in the positive direction, and one when the speed is too high in the negative direction. The order of the operators are important. If we want the alarm to act on the hardware value of this input, we select an alarm of type short and put it before the scaling operator. If we want the alarm after the scaling, select an alarm of type double and put the alarm after the scaling operator. Select the speed feedback signal, then click in the resources and select alarm short, as we want to react to the hardware side value. Click into the alarm and set text to speed too fast positive side and set limit to 20,000. Set level to warning and make sure the alarm is listed before the scaling operator in the operator table. Add another alarm after the first one and set limit to -20,000 and text to speed too fast negative side. Set limit type to below and level to warning. Now go into module M2 and rename DI00 to button and DO0 to light. We can now connect the user interface to the control application. Select the IoTest GUI app, then click Design Mode. Select the slider in the analog output group, search for CDP, and locate the CDP routing property. This is where we connect the slider to the control system signal. We want to affect the value before operators are applied, so we type in PLCnext app.plcnextio.m1.speedout.internal value. This connects the slider to the physical output in the PLCnext I/O. Select the raw value dashes in the analog output group and set CDP routing to PLCnext app.plcnextio.m1.speedout.value. This will make it show the value of the speed out after the operators are applied. In the analog input group, select the slider and find CDP routing. Type in PLCnext app.plcnextio.m1.speedfeedback.value to get the value after all operators have been run. Then select the raw value dashes label, find CDP routing and set that to PLCnext app.plcnextio.m1.speedfeedback.internal value. It will then show the speed feedback before any operators are applied. In other words, the raw value from the input. Connecting the digital IOs is straightforward. Select the Digital Out checkbox, locate CDP routing and set it to PLCnext app.PLCnextIO.m2.light. Then select the Digital In checkbox, locate CDP routing and set it to PLCnext app.PLCnextIO.m2.button. The light is now controllable from the user interface, and button presses will show as the digital input checkmark. Finally, we want to connect the IO server state. Select the current state double dashes label, find CDP routing, and set it to PLCnext app.PLCnextIO.current-state. Save the user interface by hitting Ctrl S and select Configure mode. To test the PLCnext IO, we must make sure it runs on the correct device. Pair the PLCnext and make sure you use the PLCnext ARM v7 32-bit toolkit with the PLCnext app. The video Deploy to Network Device shows how to pair and deploy to a device. We can now run the system. The user interface will run on our local PC, while the PLCnext app will run on the PLCnext target. Right-click the system, select Run and Connect. When the applications are running and connected, the user interface will show the PLCnext IO as online. When we move the analog output slider to the right, you see that the analog input moves with it. The analog input may jump around a bit. This may be due to noise in the analog to digital conversion. When the slider is moved so the raw value shows more than 20,000, the event list will display the Speed Too Fast Positive Side alarm. The alarm will show as long as the value is over 20,000 and as long as the operator has not acknowledged the alarm. When the slider is moved below 20,000, the alarm will change status from ANAC set to ANAC. If you double-click the alarm in the event list, you acknowledge that you have seen it, and the alarm will not show until it is set again. Similarly, when you move the slider to the left so the raw value becomes less than minus 20,000, the Speed Too Fast Negative Side alarm will be set. If you click on the digital output, the light output will be set, and the physical light will light up. When you push the physical button, you will see that the digital input will be checked as long as the button is pressed. That was all for this CDP Studio tutorial.